Okay. So yes, now copy down this problem, which is problem number 7 in your manual. Can you see the screen? Hello?
Yes, sir.
Yes, okay, copy down this problem. Over, I will copy it down. This is the problem number 7 in your lab manual.
So what's the length of the fillet?
Radius 8 is given, no? So it's like 1/4 of a circle. So even this distance will also be 8 mm only.
Okay, sir.
So those are completed. Make a table to write the coordinates. I will copy the diagram. Is it over? Hello? Okay, all right. So, okay, so let's start. Okay, so prepare this table to write the coordinates. Okay, so the first one will be over here in this particular place. Okay, so we'll start from this corner, right side corner, which will be x-axis. That is nothing but, see, they have not given the diameter here. They've given M12 into 1.75. So if you look at this diagram carefully, we have a grooving portion. And can anyone tell me what is this M12 into 1.75 mm?
M12 is the diameter, 1.75 mm is the pitch.
Okay, so this is a threaded portion for about 30 mm in length. Okay, right? So we have grooving, we have threading also, and till in the last class we have seen how to do up to grooving. We have not seen how to do threading, so we'll see that one also. Okay, so the starting one, that is having the coordinate point number 1 over here. Okay, so value x value is 12, z value is 0, right? Point number 2 will be here, the end of the threading portion, which is at a distance of 12 mm diameter. Height is, sorry, distance is going to be minus 30, right? Point number 3 will be here, where it will go for a diameter of 8 mm. Okay, and distance will be minus 30, and then the next value is going to be here, x diameter, that is the ending portion of the groove. So 8 mm diameter minus 36. Okay, then point number 5 will come back to diameter number 12. Okay, so diameter 12 value is going to be minus 36, and then it is going to go up to another 10 mm in the same diameter. So 12 mm dia minus 46. Right? Okay, yes, then right. So then after that, point number 6 is here. Then next one is going to be a tapered turning where the diameter increases to from 12 to it is going to increase to 20, right? And the distance will be minus 46 plus 5, so minus 51. Okay, then after that, it's going to go for a simple turning operation, so same diameter, okay, and for a distance of 10 mm, so minus 61. Then point number 9 where we are going to have this radius, okay, so here the diameter is going to increase by how much? 20 plus radius 8. How much will be the diameter? I am asking in this particular portion. Just in this particular portion, tell me what is going to be the diameter.
36.
This red color line. Yes?
36.
How much? Hello? 28 or 36. What's a month? How much?
36, I think, sir.
Yes, 36 because it's going to be diameter. Okay, radius is 8. So 20 plus 8 plus 8 on both the sides. Okay, so it's going to be 36. So be careful with that. Don't make a mistake over there. Okay, and then what's the coordinate? It's going to be how much? 36, then 10, 46, 51, 61, and here if they have not given this distance where you have radius 8, what is the distance coverage in linear? Okay, if that is not given, take it as the same value as that of the radius itself. Okay, sometimes they would have given, then you have to go along with that length only. Okay, we cannot always expect that this curve will be equivalent to 1/4 of a circle, quarter of a circle. Okay, right? We cannot say that always. Okay, sometimes it can be different also. Radius may be 8, but this distance will be only for 5 mm. So they would have mentioned 5 over here. Okay, so be careful with that. Okay, since they have not mentioned, we can assume it as 1/4 of a circle. So so distance is going to be minus 61 plus 8. So minus 61 plus 8 minus 69. Okay, next point number 10. Okay, which is going to be here end of this. So we'll be having same diameter 36 and distance will be now plus another 10. So minus 69 plus 10 minus 79. Okay, point number 11. Okay, so here we are going to have again a taper turning operation. So diameter is going to increase up to 40. Okay, distance is 5, so 79 plus 5, 84. Then point number 12, that is the end of the given diagram, the last point. So their diameter is going to be 40 and distance is another 10 mm, so minus 94. Okay, right? So these are the coordinates. Yes, any doubts with this? So next we'll take the billet diameter and length that we require for this particular thing. Okay, so we'll assume maximum diameter is 40, so we'll take 44 mm diameter of the raw material workpiece and length of the workpiece, let us take 114 mm. Okay. So yes, now let's start writing the program. So start with percentage, okay, and then the next line is going to be capital O followed by a number, right? Okay. Now the program starts. N05, okay, G21, G99, okay, N10. Yes, what is going to be the next line? Take the tool to the home portion. So G28, U0, W0, right? Then N15, we'll have, okay, tool change M06, T0101, then N20, okay. Tool has been changed, so we can start the spindle. Okay, we can start the spindle. So M03 S, we can have it at 1500 RPM, since we are going to perform facing and rough turning operation with the same tool. Okay, and then we can add on the coolant M07. Next line N25. Okay, get the tool to the nearest position to the workpiece. So G00X, will keep it at 46 mm, and Z shall be 1. Okay, and yes, I forgot one thing over here. Our condition over here is start Z equal to 2 mm. Okay, now coming back to the program. So next N30, G94, X minus 1, right? Z, let it be 1 itself. At what speed should it move? Okay, so F.2, yes, N35, another round of facing we'll do. For 2 mm of material we'll remove G94, X minus 1, Z will be 0 over here, F 0.2. Now next thing comes is, after facing is over, we'll start with the rough turning. N40, G71. Yes, what should be here? G71. Anyone? What's the syntax for what? Syntax for the rough turning cycle? Yeah. Sorry, G71. Okay. And yes. Yes, what's the syntax for rough turning? By now you should be able to tell.
U1.
That is over here. I'm talking about line number 40, N40, G71. Then there.
So U and R.
U and R will be in the next line, no? What, guys?
So U and R.
U and R only.
U and R.
Yes, sir.
Yeah. So U, how much we are getting? 1 mm. And R?
0.5.
0.5. Okay. All right. Over here, the next line N45, G71, P50. That is the from where it has to start reading the cycle from line number 50. Q, we don't know where it will end, so we'll leave it. For finishing, we'll keep 0.5 mm in X and Z direction. then F 0.2. So now the cycle starts N50 G01. Okay, so where is it going to start from? It is going to start from the first point, which is 12, 0. So X is going to be X12 Z0 SN55. It's going to be a straight line. So G01. Now here, if you look at the diagram, see from here, from the starting up to 30 mm, we have threading length, then a grooving portion for another 6 mm, then again a cylindrical surface for another 10 mm. All these complete length we have only for the same diameter, which is 12 mm. Grooving anyway, we'll be doing it later on. So before that, when we are performing a turning operation, so up to 30 mm plus 6 mm plus 40 mm, sorry, another 10 mm, all are going to have the same diameter. So this overall length is going to be how much? 30 plus 6, 36 plus 10, 46. Diameter is going to be same. So we can write that over here. Okay, so G01 X is 12 mm. Okay, Z is minus 30, 36, 46 till here. Is that clear? Any doubts over here? Hello? Any doubts? So that is, we have covered till this point now. Now next is what it's going to have an inclined surface, okay, until it reaches 20 mm diameter. Distance is 5 mm, right? So G01, okay, X is going to be 20, Z is going to be minus 46 plus 551 mm, then N65, then again a straight line G01, right? So it's going to be for a distance of 10 mm, right? So 20 mm, another 10 mm in the z axis. So from 51, it will become 61, right? So X is going to be 20 mm, Z minus 61. Yes, then after this, what is there in the diagram? Okay, let me reduce the size of this. And right. So yes, after this, what do we have? Then after this, we have a radius of 8 mm, and it's going to be in anti-clockwise direction. So what is it? In 70, G02 or G03? Hello?
T03, sir.
Okay. And Z is going to be minus 69. Then N75, G01. Yeah, it's going to be a straight line, same diameter, 36, for a length of another 10 mm. From here onwards, for 10 mm. So we have, sorry, minus 79. Then N80, G01, is it going to be? It's going to have a tapered section. So diameter will become 40. Diameter will become 40. So X is going to be 40. Z is going to be minus 84. Then N85 G01 X40 Z is going to be minus another 10 mm, no? So 94. So here the turning cycle ends. So the line number is 85. So we'll put it here immediately. N45 G71 P50 Q85. Okay, right. So after this, what are we supposed to do? So next, the tool should go back to its home position, right? So N90. Okay. So yes. So what shall we do? After this, take the tool back to its home position. So G28, U0, W0. Yeah. Right. Then N95. Okay. Then we can give it as spindle stop M09, M05, M09, then N100, M06, tool change, T0202 for finishing tool we'll select here. Okay. Then N105. So tool has been changed. So we can start the spindle M03, and now we are going to perform finish turning. So speed should be 2000 or 2500 also you can give. Okay, M07 coolant on. And then next line N110, right? Now what we can do is we can go for finish turning cycle whose code is G70 P50 Q, that is line number, ending line number 85. Okay, and then F over here, reduce the F value, we'll keep it as 0.15. Okay. Right. All right. Okay. So after this, what are we supposed to do? Okay, N115. Yes, after finish turning, let the tool go back to its home position G28, U0, W0, right? Spindle stop 120. So spindle stop M03, M05, M09, and then change the tool. So N125 line number, change the tool M06, T0303. So now in this we will select the grooving tool. Okay, now start the spindle N130, spindle start M03. So for grooving we will generally have a smaller spindle speed. So S we can keep it at around 500 RPM. Okay, and then switch on the coolant, which is M07. Then, and now what is the code for grooving cycle? Yes.
So G75.
G75, then syntax.
X and P and Q.
X and P and Q. But one second, but before this, we'll first get the tool to the required portion, G00. Where should the grooving happen? it should happen at a distance of 30 mm, right? And at a height of diameter is 12, so we'll keep it at about 14 mm. Okay, so we'll get the tool closer to the workpiece. So G00 X 14 Z minus 30, and this will become N140 for the yes. Yes, what is the syntax? G75. Syntax, please.
Radian.
Hmm? Here,
R sir, R.
where in line number 140, G75, how much? R? R1?
Yes sir.
That's for
Yes.
retract. Retract, that's all over there.
Yes sir.
And here X value will be in line number 145, G75 X until the grooving ends. So diameter should be 8 mm. Z value should be minus 36. Okay. Then what else? P1000, that is in microns. To move it in x direction, Q again in microns, 800 microns, and then we are supposed to give an R0 over here. Okay, and then feed this tool speed, that is at since it's grooving, you can give it as 0.1. Okay, 0.1. Okay, slower speed. Correct now, syntax is correct. Yes or no, anything? We left out one thing over here, G03, which is for circular interpolation. Okay, how much should be the radius? R8. Make a note of that. Otherwise, it will give an error message when you check this syntax. Line number 70, G03, X30, Z minus 69. Circular interpolation, so therefore radius as per the diagram, it's 8 mm. Yes. So after this, N150, let the tool go back to its home position, G28, U0, W0, N155, spindle stop M03, M05, coolant off M09, N160, so tool change M06, T0404. Now tool number 4 will be for threading operation. Okay, so now after the tool has been fixed, threading tool has been fixed, start the spindle. So N165, start the spindle M03. For threading operation, again speed will be less. Okay, so we can keep it as 500. Okay, and coolant on M07. Then N170. Okay. Yes, get the tool to first to nearer to the workpiece. So G00, always if you remember, while we perform the threading operation, the tool will be always from the outside, right? So when we start, the tool will start moving along the length of the workpiece, but the starting portion will be outside the workpiece, right? Away from the raw material only. We'll give the depth of cut, then we'll start the machine, right? and the spindle and the lead screw will be connected. Thereby, the tool starts to move automatically, right, along the length of the workpiece. So over here, we have to give that position. So we'll give that. So we'll give x. X value is it required over here? Okay, just a second. All right. Okay, fine. Let it be there. Okay, G00 X. The diameter is 12. Z, let it be at 1 mm or 2 mm. Okay. Yeah. Yes. Now we'll go to the threading cycle N175. Yes, the code for this is G76. Syntax, let us see the syntax now. Okay, so for threading cycle, what should be there is that the format is, see, G76. It should have a value of P, okay, where it has got three requirements for this: M, R, and A. What is this M? M is number of passes, idle passes after the last cut. Okay, so how many number of passes we want it to happen. Then R, okay, chamfer distance at the end of the thread. Okay, so usually if you look at a nut and bolt, at the end of the bolt, you cannot see a sharp thread continuing. It will be slightly chamfered on that right side end. Okay, right. So that is there. Then A is going to be the angle for the tool that has to slide over the workpiece. So if you remember that in the machine shop, okay, we'll use a threading tool which will be very sharp, okay, and that is the tool tip angle that we are going to give over here, right? So these three parameters will be, these three details will be put up in the value of P. Then Q will be the, okay, Q will be what? The minimum depth of cut in microns, right? So if you remember the threading operation, okay, to remove, say for example, to have a thread of 1.5 mm, okay, you would have done about 5 passes or 6 passes, right? So at every pass, how much should be the depth of cut? Okay, like you would have given 0.1 mm or 0.2 mm, you would have given, generally not more than that. Okay, so that should be represented in microns. Okay, that should be represented in microns, where it will come for Q. And after that, what should be the finishing allowance? Because when we are doing this, we are only doing initially rough threading. We'll try to remove it as quickly as possible. And in the last pass, we'll try to move the, we'll try to give very small depth of cut, okay, as it approaches the minor diameter. So how much should that be left out? Is the R value, finishing allowance, again in microns. Is that clear till here? Hello? Hello? All right.
Yes, sir.
Okay. Right. Next is what? Again, G76 in the next line. We have to give what is the minor diameter for, that is X value. X and Z coordinates at the end point of the thread. What should be the minor diameter? Okay. Right. That we'll be giving up over here. And this R and P is not required. This is not for this particular format. Okay. Thread depth, radial value, depth of first cut. Okay. Right. And 1 second, taper value positive. Right. Taper value positive. All right. Okay. We'll say that there's a slight change with this. Okay. Right. Okay, so let's write this. So before doing this, we have to do this thread calculation. So they have given what M12 into 1.75 is the thread that they're given. So first thing that we have to find out is the thread height. What is the height of the thread? Okay, so for that, pitch of the thread is already given, which is 1.75 over here only, right? This is the pitch of the thread. So we'll assume that it is going to be an ISO thread. So for that, it is going to be 0.613 into pitch of the thread. So here it is going to be 0.613 into 0.75. How much is it? How much it is going to be? $1.07275. Right? So that is going to be how much in microns? 10727.5 microns. Correct? Hello? So after this, so we have the height of the thread, okay, minor diameter, okay, so x is going to be 20, sorry, here it is going to be, the diameter is how much? 12, no? 12, okay, minus 2p, okay, right? From there, it has to reach to the minor diameter. So here we are going to get 12 minus 2p, that is going to be 12 minus 2 times the height of the thread, okay, right? So that will give us how much? 1.07275 to 2, yeah, and then 12 minus this 2 times, okay, here we are going to get 9.8545. So this is going to be the minor diameter, 9.85 mm, right? Okay, major diameter is going to be 12 mm, minor diameter is going to be 9.85 mm. Okay, is that clear? Write this calculation, take down this calculation, because without this calculation we cannot fill the data in the syntax for threading. Okay, just a second. Okay, yes. Start. All right. Okay. Yeah, please copy down this calculation. Thread cutting calculation is required. Is it over? Hello?
Yes, sir.
Yes?
Yes, sir.
Okay. So yes. So now we'll see the syntax once again. So then you'll understand a little bit. Okay. So here in the first line G76, P here in the place of M we'll replace by how many times the tool has to, by how many passes we want the tool to pass. Okay, 3 passes or 5 passes will give. Then R, okay, what is the chamfer distance that has to be taken care? Okay, that will give, say for example, that is usually 1.2 times the lead. Okay, right? So we'll generally give 10 or 12. Okay, that will be giving over here, or even sometimes 15 also, not more than that. And in the place of A, we'll give what is the angle, tool tip angle, which will be usually 60 degrees for thread cutting angle. Then Q, okay, will be the diameter, okay, Q minimum depth of cut in microns. Okay, so for every pass, by how much should the depth of cut be? 100 microns or 200 microns, because it's going to be a cycle. We have mentioned, say for example, in the place of M, we have told 5 passes, right? So we'll tell here, in then after that in this place Q, we'll tell what should be the depth of cut in each pass. Okay, so we'll give that value in microns, generally 100, okay, or 500 also we can give. Okay, then next thing will be what? Next thing is we'll be going to R of D. Okay, R of D, finishing allowance. So we have to leave some amount of material over there in the material. So that will be about 0.15 mm generally, and that will put it in this place, R of D. The next line G76, X value will be here is the minor diameter, where we'll get it from this calculation, right? X is equal to diameter into minus 2 times the pitch. Okay, right? And then Z value up to which place? Okay, right? So that will be giving up over here. And then R of I, right? This is not required for us. Okay, P of K is required in the actual syntax. Thread depth, uh, okay, in microns, the radial value. Okay, thread depth. Okay, that is nothing but the height of the thread. Okay, thread height. So that is nothing but that is what we have calculated here. 0.613 into pitch of the thread. Okay, so that will be in microns. This value will be in P of K. And then Q of D, what should be the depth of cut in the first pass? Depth of cut in the first pass, okay, over here. Okay, because even if you remember your machine shop, first depth of cut will give a little bit heavier. Okay, right? So that the tool does not slip over the when it passes over the raw material, so that that helix groove is being formed. Okay, right? And then the feed. Okay, okay. Sorry, not the feed. Whatever is the pitch of the thread, that we'll be mentioning over here, not the feed. Okay, right. So yes, so we shall go here. So G76. Okay, capital P. Number of passes, we'll keep it, say, for example, 3. Okay, and then what is that? PR, and what is R? Chamfer distance, we'll keep 10 or 15. So 15. Tool tip angle 60 degrees. Okay, and then, right, then what is there? Q. Okay, Q, that should be the minimum depth of cut in microns. For every pass, how much should be the depth of cut? So we'll give 500 microns. How much is 500 microns, guys? In mm, please. Yes. Point 0.01, sorry, it's 0.015, because
0.5 mm, sir.
yeah, so 0.5 mm is what we'll be removing every time. Okay, right? So that is why I've given Q is equal to 500 and 180, again G76. Okay, then what is there? X, where we here we'll put the minor diameter. How much is the minor diameter? 9 point something we got, right? 9.85. Okay, 9.85. Okay, and then Z value, sorry, Z minus 36, because it has to, sorry, not 36, it has to go from starting to a length of 30, right? So here we can give it as 30, Z minus 30. Yes, then what is there after this? We need, okay, we have to give this R0 plus this, just give this R0, otherwise in this version of the software it will give an error. Okay, and then P, okay, so here we'll give the thread height in microns. Okay, it's going to be 10757. So 10757. Okay, and then Q. Okay, Q is going to be what? Q will be the depth of cut in the first pass, right? So we'll give that in, for example, 400 microns, and then F is the pitch of the thread. So here in this case, they've been 1.75. Yes, any doubts here? Hello? Any doubts? No doubts? Okay, so after the threading is over, okay, so send the tool back to its home position. Then the next line, spindle stop M05, M07, right? And then N195, M30, end of program, and then percentage symbol. Let me put this. Still more. Yeah, copy down this program. Just a second. Okay. 854 Z30. Sorry, here we'll make it as 50 microns. Here we'll make it as 100 microns. Yeah, is it visible clearly?
Yes, sir. Yes, sir.
Yeah. Copy the program so that I will show you the simulation for this program. Over. I will copy the program.
Yes, sir.
Yes. Okay. Others?
So done, sir.
Done? Okay. Okay. Shall we see the simulation?
Yes, sir.
Yes. Okay. So, okay, let's go to the simulation. It's okay. So here, I've already typed the program in Notepad, and I'm going to just copy paste that. So we'll go to CNC turn software, open an existing part because, if we have already typed it, okay. So problem number 7, I'll select that particular file. So the program gets loaded over here, okay. Right, okay. So length, so go to the blank and give the length, okay. We need 94, so another 10 or 20 mm, so 114. Maximum diameter is 40, so here we have taken raw material diameter as 44, and as usual, as per our method, we'll take start Z at 2 mm, okay, where this 2 mm will be removed for facing. So next, we'll go to machine, okay, select a machine over here. Then we'll go for error check, okay. Here what will happen is when you are doing it for the first time, when you do error check, okay, it will give you error. It will give you error. I'll just show you here. I'm not getting it here because the tool is already assigned. Okay, the tool is already assigned. So here all the 4 tools that we need for machining is already there. Thereby in error check, I'm not getting any error. So I'll just delete these tools. Okay, no tools are now selected. Okay. Now, first thing, go to tool number 1. Okay, here we'll give the rough turning tool, okay, PCLNL R8. Okay, and then tool number. Okay, all right. So just a second, I'll just remote. So here no tool was selected. So if I do error check, just look here at the bottom in this white color space. T01 tool not defined, T01. Again, same thing, tool not defined, T02. Same thing is repeated for all the 4 tools. Why? Because no tool is being selected. Okay. So first thing what you should do is you have to go for, before doing the error check, assign the tools also. Okay. Assign the tools. So select tool number 1, which is used for pacing and rough turning operation, PCLNL R0.8. Then tool number 2 for finish turning, Same shank size 16 by 16, PDJNL R.2. Right. And tool number 3 is for grooving. Yeah, so we'll go to external groove, and in that grooving again 12 by 12 shank size. Okay, depth will get around 8 mm, which is sufficient for us because from 12 we have to, the raw material diameter is 12 mm, and from there it has to be reduced to 8 mm. So 12 minus 8, only 4 mm. So this tool is enough. Then tool number 4 for threading. Okay. And then we have to go for external thread. Okay, we have an option called external thread, shank size. So we'll go to external thread. Then in that, again we'll select external thread sub option. Okay. And in that we'll go for 16 by 16 is the shank size. Okay. Tool tip angle that is going to be 60 degrees. Okay. For left hand thread. Okay. For left hand thread, you can select this. Yes, so now the tools are assigned. Now I'll do error check once again. Check for if there is any errors. No errors. Right? No error at all. Okay. So now let me adjust by clicking on zoom limits. Let me adjust the raw material to the screen. Now let's start. Now let's see the simulation. First is facing. So you can simultaneously, you can see which line number the system is reading, where that particular line will be enlightened with in blue color. Next, we are going to get the finishing tool, which is removing that 0.5 mm of allowance that we had left. Okay, now comes the grooving tool. Retract by 1 mm. Here, let it completes. Yes. Can you see here that even here also? Yes. Can you see that once the tool, I'll just replay it. Just look here carefully. After the grooving operation, where did the tool go? It went to this particular portion, and that is to the right hand side corner. At the end of the right hand side, it damaged this, it hit this workpiece at the right hand side. And that is why you can see that there is alternative lines over here, right? Okay. And the same thing after the threading operation, just look at it carefully. Yes, can you see that it's a kind of V shape with a sharp tip where the tool will just travel over here, hit the workpiece and go back. Can anyone tell why is it? Hello? Yes, anyone? Why did it happen so?
Was it too fast, sir?
No, if it is too fast, why is the tool traveling to the, after the operation, the grooving tool and threading tool is traveling to the right hand side and damaging the raw material? When it machined it.
Sir, our chamfer angle is not correct.
No, but for grooving, forget about threading. See this picture over here where I stopped. Just see the screen. It is damaged in this particular place, right? Can you see that?
So too much stress in that area, sir.
No, but why did the grooving, if you look at it, see, after grooving operation, you just look at it carefully. See, where did the grooving tool, after finishing operation over here, it should have gone back, right? Directly. Why did it come here? There is no grooving operation onto this right hand side. Okay, just see the corresponding line onto the program editor in this yellow color space, line number 155. What is there?
It is to home position 0, 0. That is why.
There should be U0, W0.
Yes, exactly. It should be U0, W0. If you give X0, Z0, where is X0, Z0 actually? It is onto this right hand side center of this material. So the tool traveled till there because you have given X0, Z0 is where? Onto the right hand side of the workpiece, correct? No? Right? So this is what will happen if you give in G28 X0, Z0 instead of W0, sorry, U0, W0. If you give, this is what will happen. So always use U0, W0 instead of X0, Z0 for G28. Okay, because this you will face sometimes when you start doing the simulation, even in your exam also. And then you will see that everything is correct, my program is everything is correct, but still why is this happening? It is just because of this. Okay, so I'll just show, see even for, see line number 190, I have given again G28 X0 Z0, which is after threading cycle. That is why over here also the threading tool will damage the workpiece at the end, not in the beginning or somewhere in the between, at the end. Is that clear? Okay, so next. So what I'm going to do is, so you just look at the program editor, this yellow color space, I'll be changing G28 X0 Z0 to G28 U0 W0. But this, it did not show this problem in error check. There was no errors at all. Yes or no? Right? So don't think that every, even a small thing will be shown in the error check. In error check, it will majorly check the sum of the values and especially the syntax. So I'm changing N95G28U0W0 and the same thing to N190. Okay, and line number N190. I'll save the program. Okay, once again, I'll run it. I'll see the blank size, save the program, check for any errors. Tools are already assigned. Save the program. See, always whenever you start the simulation after making any changes, save the program, and only then go for syntax check. Okay, and then for simulation. So now just look at it. I'll just play it once again. See, so just check now. After the grooving tool, it has done its operation. See, it did not touch, it did not come to 0, 0 position at all. Okay. And even in the threading operation also, you can see the same thing. Yes. Is that clear? Any doubts? Hello? Any doubts?
No, sir.
Right? Okay. So here today we have seen grooving, which we have already learned, plus with that additional thing is threading operation. Okay, so we have learned something over here, the threading calculation, then threading syntax for threading operation. Okay, and how to incorporate this threading syntax into the programming also. Okay, is that clear? Yes.
Yes, sir.
Yes. Okay. Now, okay. Yes. Copy down this diagram. Number 8. Oh, no, this was actually problem number 5, 6, 7. Yeah, this is actually problem number 5. Right. Right. Yes. Copy down this diagram. ಹೌದಾ? Over copied it down. Hello.
Yes, sir.
Yes. Okay. So here if you look at this diagram, we have grooving, threading, and drilling. Okay. So just in the previous program, we have done till grooving as well as threading also. Okay. So the newer thing will be drilling. We'll see that. Okay. Right. We'll see that when we write the program. Okay. Now for this, start writing the program. Start writing the program for this. First prepare the table. Okay. write the coordinates. Okay. This one. Okay. Right. So you write the program till. If you know the complete thing, you can see the manual, you can write it, but don't copy the same program that is there in the manual. Okay, there are errors in that. Okay, you have to debug it. So don't think that it is the same thing. Everything is clearly written in the program that is, all the major steps is being written, that's all. Okay, so don't think just if you type that program that is there in the manual, you will not get any error. You will get errors from that. Okay, right? Okay, so this is for your homework. Okay, we'll complete this problem. Okay, complete this problem. Okay, we'll see this in the next class, right? Or you'll do it today only.
So next class, sir.
Next class.
Okay, right. 1 second. Let me take the attendance. Okay. Yes, Niharika.
Yes, sir.
Okay. Nihar Venkat Sai.
Yes, sir.
Nikhil R.
Sir.
Okay. Then Nilesh.
Present, sir.
Neerab.
Yes, sir.
Rajwal R. Patel. Rajwal R. Okay, he's not there. All right. Rajwal S. Bhatt.
Present, sir.
Okay. Prince Tagore.
Present, sir.
Okay. Rishabh Pandey.
Present, sir.
Rohan. Rohan. Okay. Then Roshan Yadav.
Yes, sir.
Okay. Suman Sagar.
Present, sir.
Okay. Sagar GV. Sagar GV not there. Then Sagar Dutt Mathur. He's also not there. Then Sanjay Raghav.
Sir.
Okay. Sharanya Hiramat. Sharanya. Okay, he's there. Okay. Then Sheikh Manan. Sheikh Manan is not there. Shobit.
Present, sir.
Siddharth B. Shankar.
Present, sir.
Siddharth Sridhar. He is not there. Siddharth Sridhar is not there. Okay. Then Subramanya.
Present, sir.
Yes. Tirumana Shetty Rohan.
Yes, sir. Yes, sir.
Okay. All right. So yes. So in the same manner as just we wrote the program with the same thing. Okay. Try to write the program for the given diagram. Okay. Right. So we'll do that in the next class. Right. Okay. Thank you.
Sir, I'm present.